Hello everyone, welcome to this session. So in this session, we will discuss the systematic way to identify outliers and remove them. So particularly this Z-Score and the IQR method. So let's see the Z-Score method first. So let's see, you have seen this figure in the last session. So this is like Gaussian distributed, and there is an outlier there. So how to identify the outlier? A straightforward way is to calculate their Z-score. We can see the Z-score, the calculation is x minus mu. So mu is the mean of the data set, and divide the sigma, standard deviation of the data set, right? So the result is a Z-score. So we can apply Z-score to every data point in this set, right? So then the question is that what Z-score is telling us? So Z-score is telling us how many sigma, standard deviation, is away that the data point is away from the average mean, right? So we can see that's why I minus mean with the result divide the standard deviation. So clearly the larger the number of standard deviation, the data point is away from the mean, the more likely is an outlier, right? So we can see the Z-score to judge it, right? So let's see how to implement the Z-score. So this is the data, as we can show here. Now I write the following programs. The raw data is x, right? And I want to remove the outliers, which is here. So now what I do is that I first calculate the Z-score of each data. So then I have the same size of the Z-score values, and one-to-one correspond to each data point. So then what I do is that from 1 to the size of z, I said if the Z-score of the ith data point is larger than 1, then I think it's an outlier. So you can change the number here. Maybe you can say 2 or 3. This you can see that is your criterion to see which one we can cut into the outside is the outlier, right? So here I use 1, and then if it's an outlier, I put it to the outlier array, and then I remove them here. Then after this program, you can see this. This one is clear, and these are the remaining data, right? So you can see this in the live script, and you can try yourself by changing this value and see what happens. Right. So in Z-score, what we assume is that the data is Gaussian distributed. So that's why we can first minus is average, then I divide is a standard deviation. Sometimes the data is not Gaussian distributed, and the Z-score method also works if the data is near Gaussian distributed. So next we will introduce a method, we call it the IQR method. But this method, it works for any distribution, Gaussian or not Gaussian. So let's see how it works. So here we can see a data distribution, no matter is what. And then we can find the Q1 and Q3. So what is Q1 and Q3? So Q1, this is a 25th percentile. So what is 25th percentile? This means that 25% of the data is smaller than this. That's the value in Q1, right? And Q3 is a 75th percentile. So we can see that with Q1 and Q3, according to this data distribution, we can find the median is here, the Q1 is here, and the Q3 is here. So Q3 minus Q1, this is the value of IQR, right? So then, when we see we can consider if Q3, we go to the right? So add 1.5 plus IQR. This is on the right side. And on the left-hand side, we use Q1 minus 1.5 multiply IQR. So in this way, the data point outside this range, so you can see is here or here, we can think that they are far enough from the median, so we consider them as an outlier. So you can see them in the live script and try it yourself. So Now we implement the IQR method. Again, this is the data. The program is here. So I first use a MATLAB built-in function, PRC tab. So this function, you can check it online to see how to use it. We can use this one to get the 25th and 75th percentile. And now I get the IQR value. So then I wrote here is if on the right-hand side or the left-hand side, if out of the bound, I think this is an outlier. Then I remove them here. So after this program, we can see the result is here, right? So you can also try it yourself in the live script. So that's all for this session. Thank you very much.